Welcome to Cardiac Academy. In this video, we're gonna continue our discussions on EKG interpretation. We're gonna talk about how to tackle EKGs in a systematic way following our very own mnemonic. After that, we're gonna talk about the EKG paper and its different calibrations. And then we're gonna finish up strong by discussing how to calculate heart rate. So without further delay, let's get into it. Okay, my friends, let's get started. So when approaching EKGs, we should really do it in a systematic way, because when we don't, it becomes extremely easy to just miss things. So at the Cardiac Academy, we came up with this mnemonic, and the mnemonic is erratic. So why erratic? Because we don't want you to be erratic when approaching EKGs. We want you to be systematic. So by following our mnemonic, you'll always know what to look. You're always gonna do it in the same way, and it's gonna minimize the risk of missing things. So let's go over our mnemonic. Okay. So first, we have E. And the E stands for EKG and for just to make the mnemonic work. After that, we look for the rate, which is the first R. After we assess the rate, we'll look for the rhythm. Okay? A is for axis. T is for QT interval. I is for ischemic changes. And finally, C is for chambers. So throughout our video series, we're gonna go into each one of them and we're gonna discuss each of them in detail, okay? Very good. Okay, my friends, let's talk about heart rate. So before we start calculating heart rate, we should spend a few minutes talking about the EKG paper. So the EKG paper is made up of small boxes and big boxes. And each one of these small boxes is 1 millimeter in length, okay? And depending whether we're talking about the horizontal plane versus the vertical plane, they're gonna represent different things. So on the horizontal plane, each one of these small boxes represent 0.04 seconds. So it represents time, okay? And when we add up 5 of these small boxes, then it represents 0.2 seconds. So each small box, 0.04 seconds. One big box, which is made of 5 small boxes, represent 0.2 seconds, okay? That's in the horizontal plane. Now, in the vertical plane, it still measures 1 millimeter. However, they represent 0.1 millivolts, okay? And 5 of these add up to one big box, and one big box represents 0.5 millivolts, okay? So for these calculations to be accurate, we need to talk about the calibration of the paper, okay? So when we're talking about calibration, there's 2 things we need to check. First is the time, or the EKG paper speed, which by convention is 25 millimeters per second, okay? And sometimes some cardiologists will slow down the speed of the paper, and this is gonna make the waves wider and it's easier to assess the morphology. So that's why you can increase or decrease the speed of the paper. Now in the vertical plane, we talk about the calibration pulse, okay? And the calibration pulse is this structure that you can see inside this red rectangle, and it gives us the standard size of the amplitude of the paper, okay? So by convention, it should be 10 millimeters, or 10 small boxes are gonna represent 1 millivolt, okay? So let's write that. So 10 small boxes equal 1 millivolt, okay? So whenever you're gonna read an EKG, you have to check both. Check the speed of the paper, make sure it's 25 millimeters per second, and that's usually stated at the bottom of the EKG paper. And then check the calibration pulse and make sure that it's 10 small boxes or 2 big boxes, which is the standard, okay? Sometimes you can increase or decrease the calibration pulse depending on what you want to see. If the amplitude of the wave is too short, then you could increase the calibration pulse to make the waves be taller. And in some occasions, the waves are too tall and they go up beyond the paper. So in that situation, you will shorten or make smaller that calibration pulse to make the wave shorter, and then that way you can assess the EKG. Now, you need to be aware that when you change the calibrations, then all of these numbers that we just discussed are going to be different, okay? So again, just to review a little. So before reading the EKG paper, make sure it's 25 millimeter per second, and make sure that the calibration pulse is 10 millimeter per millivolt, okay? And after that, then remember, each small box is gonna be 0.04 seconds in the horizontal plane, and in the vertical plane, each small box is gonna equal 0.1 millivolts. All right, very good. Let's continue. Okay, my friends, let's calculate heart rate. So if you search online, you're gonna find multiple ways of doing this. Now, I'm gonna teach you my two favorite ones, okay? So in this first method, you have to memorize these numbers, okay? This one right here, and it's gonna make things easier. So the way to use this first method right here is you're gonna look for a QRS that falls in a thicker line, and then you're gonna start counting the big boxes in between QRS and QRS, okay? So this one here falls in a big line, and you go like this: 300, 150, 100, 75. So in this case, we have 75 beats per minute. Now, alternatively, what you can do is just take 300 and divide by the number of big boxes. So in this case is 4 big boxes, and that equals to 75 beats per minute. So you end up with the same result. Now, I like just memorizing these numbers and count. I think it's quicker, but some people are good at math and they just can make the division in their mind. So you can choose either way. Now, the second method, down here. This method, you need to learn it no matter what, because when the rhythm becomes irregular, then you can't really use the first method, because there's gonna be too much variation between QRS and QRS, and your heart rate is gonna be inaccurate, okay? So the second method goes like this. It's easy as well. You're gonna count the number of QRS in the rhythm strip, and that's important. It has to be in the rhythm strip, okay? Because if you try to count in another lead that is not a rhythm strip, then your calculations are gonna be inaccurate as well. So in this case, you just count the number of QRS and multiply by 6. So let's do that. So let's count 1, 2, 3, 4, 5, 6, 7, 8, and 9. And 9 multiplied by 6 equals 54 beats per minute. And in this case, since this rhythm strip is regular, we can use the first method as well. So let's try that. So we go like this. We look for a line that is falling in a thicker line. We have this one right here, and we count 300, 150, 100, 75, 60, and 50. So this line over here is kind of falling in between 50 and 60. So between 50 and 60, we can say 55 beats per minute. So as you see, we can end up with the same result, 55, 54, no matter the technique that you choose. So pick one and stick with it. Now remember, if the rhythm is irregular, you have to choose the second method, okay? Very good. So now, let's do some practice questions, okay? So each of these are rhythm strips, so you can really use both of these methods, and I encourage you to do both so you can practice, okay? So feel free to pause the video, do all of them, and then we'll go through them together, okay? Very good. Ready? Let's go. All right, so let's start with the first method in this rhythm strip. Let's look for a QRS that falls in a big line. We can see one here, and let's start counting. So we say 300, 150, 100, 75. So 75 beats per minute. That's the first method. Now let's do the second method. So let's start counting QRS, and we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 60. 1 and 2. That's 12. So plus 12 equals 72 beats per minute. Same result. 72, 75, pretty close to each other. Okay, very good. Now let's do the second one. So looking at the second one, there's something that we need to notice on the rhythm, and it's that it's irregular. So we see here the distance in between this QRS and this QRS, and then we look at the distance between this QRS and this one, and we see that it's different, it's irregular. So in this case, we can't really use the first method because it's gonna be inaccurate. So here, by default, you need to use the second method. So let's do that. Let's count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 60 by 6, 60. 1, 2, so that's 12 equals 72 beats per minute. Right, great. Let's do the third one. We look at the rhythm, it looks regular, so we can use either or both methods. So let's do the first one. We look for a QRS that kind of falls in a big line right here. We count 300, 150, 100, and 75. It kind of falls in between. So it's between 100 here and 75. So we could just estimate to approximately 85 beats per minute. We can also just count the number of boxes, and we said there are 1, 2, 3.5, and you divide 300 divided by 3.5. Okay? Now let's use the second method. Very good. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 60. 1, 2, 3, 4. That's 24. Plus 24 equals 84. So pretty close. Very good. Now let's do the last one. So in the last example, again, we notice it's irregular. Here is longer than here to here, and again here to here. So the rhythm is irregular. So we can't really use the first method. All right. Let me clean this up a little bit. So let's do the second method. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Plus 60 plus 1 plus 6, which equals 126 beats per minute. All right, very good. All right, my friends, so this concludes our video. On the next video, we're gonna start talking about rhythm and arrhythmias. So I hope you like our videos, and I'll see you on the next one.